Okay, so today we're talking about area, perimeter of rectangles. Just a couple things to consider when considering area of a rectangle. It's predominantly length times width. Keep in mind your length will always be longer than your width. So, if your width is 5, then your length should be something greater than that, let's say 9. And if you're doing length times width, 9 times 5, that's 45. That would be your area. Now, let's take that same rectangle with perimeter and the understanding that in a rectangle, your lengths or opposite sides are congruent. So if this is, whatever this is, L, same variable here, L, W and W. So for instance, if I had this 9 and 5 rectangle, if this was 9, this here would be 9, and this would be 5 and 5. Adding up 18 and 10, perimeter would be 28. So a lot of what we see as a perimeter formula is 2L plus 2W, meaning 2 times the length, 2 times 9, plus 2 times the width, 2 times 5, 18 plus 10, 28. That's what we see there. Now, if you're ever presented with a question that gives you an area, let's say we're saying area is 60, and they're going to give you one of the sides, and say the side is, let's just say in this case 6, and you're solving for the length. That's just simple. It's just 6 times what length is 60 there. Length would be 10. So anytime you're solving and they give you area and missing a side, you're just simply. Now, let's say they give you the same thing and tell you your perimeter is 54, and they want to know what is the length. Well, it's 2 times the width, so 2 times 6 plus 2 times the length gives you a perimeter of 54. So you have 12 plus 2L is 54. Subtract both sides by 12, and then you get 2L is equal to 42. Divide by 2. 40 divided by 2 is 20, 2 divided by 2 is 1, so your length here would have been 21. And that makes sense, because if I put all these units in, this will add up to give me 54. So here's just some maybe algebra, or what we like to call sometimes GEOGRABRA, where you have the geometry question that involves some level of geometry. Now you will have some questions like this here, where they're giving you an expression. They're giving you an expression for the rectangle. Now, anytime we're working with this, especially on the SAT, a diagram is very necessary. So first, right away, I want to create a rectangle here. And I want to read what it says, 3 centimeters less than 2 times its width. If the area, okay, so they're giving us an area of 54. If the area is 54, find the length and the width. Well, 3 centimeters less, how do you say that? A lot of students will say 3 minus 2W, where actually it's 3 centimeters less than 2 times the width. So actually, if I don't know my width, and it's saying my length is 2 centimeters or 3 centimeters less, this is how I'd write it. Now, in reality, this is my length here, and this is what they're telling me, the length of the rectangle. So I had to come up with an expression for that. Now, remember our formula for area is length times width. This is another GeoGebra problem because there is some. Now, I'm going to distribute 2W squared minus 3W is equal to 54. And there's this idea in in math, in algebra, where if you get a quadratic formula, right? If I'm able to bring this 54 to this side by subtracting 54 from both sides and set it equal to 0, I can essentially find what W is equal to, right? I've created this, what we call quadratic equation here. And quadratic, not 4, but in math, quadratic means square, because if you think a square has 4 sides, so that's what this is coming from. Now, I'm sure you've seen in the past some form of foiling, right? Where you do first W squared, outside minus 4W, inside minus 3W, last plus 12. And then you combine like terms and you get W squared minus 7W plus 12. Well, we're gonna do the same thing here, but we're gonna work in reverse. We're gonna kind of try to figure out, what would need to go in the parentheses is in order to give us this. Now, what I do is I take my factors from this first term, 2W and W, and then I take a couple of my factors from this term. Let's just use like 1 and 54, 2 and 27, and 6 and 9, right? And what I'm trying to do is match up this first term with one of these last terms here. And this is a little bit of insight into Algebra 2. And if I matched up 2W with 6, right? And I want a negative in the middle. So if I match 2W up with 6, a negative 6, let's say, I will get negative 12W. And if I match up the W with the 9, now if I use 6, I have to use 9. So because 6 times 9, I want to equal 54. So W times positive 9 will give me a positive 9W, and I have my negative 3W. That's what I have here, right? Now this takes a lot of practice, but it is good to see now. So what did I do? I did 2W times a negative 6, and I did W times a positive 9. And if you see, 2W times W, 2W squared. 2W times negative 6, negative 12W. 9 times W, 9W. 9 times a negative 6, negative 54. Now don't forget, this is equal to 0. And if you know in multiplication, if I'm able to get a 0 in any of these, this will be equal to 0. For instance, if I did 2W plus 9 times 0, I have a 0. So what does W need to be in order to be 0? Well, let's just solve for it. W minus 6 is equal to 0. Add 6. Add 6. W is equal to 6. This is a possible value of my width, right? By solving this, I found that my width is 6 here, right? Now, watch what happens here. I'll do this another color just so you can see it. 2W plus 9. I want this to equal 0. Minus 9 minus 9. 2W is equal to negative 9 over 2. Now, this is a negative number. W is equal to negative 4.5. This makes absolutely no sense, because how could you have a distance of a rectangle, distance of a side negative? So I know that's not my answer. So I found that my width was 6. So if my width is 6, and I do 2 times 6 minus W minus 3, 12 minus 3, I get 9. Well, 9 times 6 is that area of 54. Now, if they give you multiple choice answers and you see that 9 and 6 there, and you recognize the length needs to be longer than the width, well, then I would go with that. Now, here's a quicker way to do this what we call finding zeros, right? There's a couple quick ways. One is to just simply put this equation that we came up with, this 2x squared minus 3x minus 54 on a Desmos, right? We put this into Desmos, desmos.com. And And when graphing it, it shows us 2 points that intersect my x-axis. And those 2 points actually give me my zeros without doing any of that unfoiling. So I end up with x equal to 6, right? This is my x-coordinate, and negative 4.5. And I know that the distance of a rectangular side can't be negative. So here I found the 6 here. You could do the same with a TI-83 calculator too and put your 2x squared minus 3x minus 54. You could graph that. This graph is a little bit off. I'm gonna go second zoom. Nope, that's format, quit, zoom. And then I'm gonna go down to zoom standard, and what that does is basically resets my calculator. Now keep in mind, we understand these are our values for x right here. X can't be negative, so I'm gonna solve for the one that's positive here. Now in order to do that, I do second, calc, and you have a 0 function here. Great tool for the SAT. And then here it says left bound. So I'm gonna find my cursor. Where's my cursor here? Okay, here it is. Oh, try that again. Now I know where my cursor is by these coordinates here. So you see that I have x is 6. So when it says left bound, you wanna put the cursor to the left of the intersection, enter, right bound, put it to the right of the intersection, and then hit guess, it does that, and then here's a 0. Again, it gives me x equals 6 as my 0, so I'm able to do that here on the calculator. I know I just drew on the calculator, I'll wipe that off there in a sec. So that's another way to find your 0.